Hello, everyone, and welcome to Waterfalls 101, another discussion from Strangeloop about web performance and web performance analysis. My name is Hooman Beheshti. I'm the VP of Products at Strangeloop. And today I'm basically going to teach you what a waterfall is, what we use it for, and how you can use it to analyze performance of a website and to see, get some visibility into what's happening when pages are loaded. Let's start simple. What exactly is a waterfall? A waterfall for us is, we at Strangeloop spend a lot of time analyzing performance. We spend a lot of time looking at pages and seeing where performance problems are and how we can help them. The best way to visualize it for us is what we call a waterfall chart, which is what we're going to talk about today. Essentially, a waterfall chart is a visual representation of what a browser does when it loads a page. It gives us very, very detailed and granular breakdown of the page and the components that are in the page, basically what the browser does. It shows us some network activity. It actually tends to show us some client-side activity as well, because it sort of shows us when the client goes and fetches different things. And it gives us a lot of timers that help us understand what a performance of a page or a site is, and how each of the different components are affecting that performance. Let's see what it looks like here. So this is a very simple one from the very, very lean Google homepage. So if you look at Google's page, these are some timers on it, and here's a simple waterfall for that page that shows some of the resources that come down, some of the timing associated with the resources. We'll talk about these colors and these timings in a second. Some of the timings associated with those resources, and basically it's a visual representation of what happened when we're going to that home page. Now, there's a number of tools available. There's a number of different ways available for us to get waterfalls and analyze those waterfalls. The two that I personally like the most are outlined here on this slide. webpagetest.org is a free online tool that can be used for spot checking and testing different pages. It is a very, very good tool. I probably spent 30 or 40% of my days on webpagetest.org analyzing different sites and getting insight into what's happening on different sites. It's a great tool. It's an online tool. The only drawback to it is that it can't let you test internal apps, things that are not exposed to the public. But it does give you great detailed reports. The other tool that I like to use a lot is something called HTTP Watch, which is essentially a desktop app, but it can come as a standalone module, but mostly it's a browser plugin. So you install it on IE or Firefox, actually, go to a page, navigate the page, and get analysis of what the resources look like. It does give you the added advantage of analysis of flows, which is a little bit easier. And you can use it on internal applications. So if it's on your browser and you have an application that's not accessible externally and webpagetest.org just won't do, HTTP Watch is a good tool, except it's not free. That's the other thing that we should know about HTTP Watch. Let me show you quickly what these things look like. This is webpagetest.org. This is the interface. As you can see, it's an online tool. You enter the website's URL. There's a number of metrics and a number of settings that you can set for the test itself. This is a slide, so I can actually navigate through these right now. But you basically select this a location that you test from. There's all sorts of locations available. The Dulles, Virginia. This is an AOL-sponsored project, or an AOL-associated project, if you will. So the Dulles AOL facilities on the East Coast. There's a data center. There's a testing node in San Jose. There's a testing node in Chicago, New York. There are new ones in Europe and Amsterdam, and Paris, I believe. There's a new one in South America. There's one in China. There's some in Australia and that region. I believe New Zealand has one. So lots of different test locations and lots of different browser combinations. We know that browsers consume pages differently. So webpagetest.org offers IE 7, 8. I believe there's a 6 instance. And I also think 9 beta versions of IE9 are making it onto the test bed. Different connection speeds. There is the standard DSL. There is higher connection speeds, and it's actually customizable. So you can sort of pick and choose what the access speed is and what the latency is, and maybe even simulate some packet drop. It'll measure first and repeat views, and it gives you a little bit of scripting capabilities as well. It's a little bit more advanced, if you will. So this is what webpagetest.org looks like. This is what HTTP Watch looks like. So like I said, it's a browser plugin. This is IE, again, the Google page. This is what a waterfall on HTTP Watch looks like. You go to the navigate to the page. There's a little record button that lets you record the resources on the page, and that's it. You can see all the timing issues. By the way, feel free to submit questions throughout the webinar. I'm getting into questions at the end. Submit them during the webinar if you like, and we'll just collect them and address them once we're done. Anyway, this HTTP Watch, we already talked about Web Page Test. These are not the only tools that are available out there. They happen to be my favorite because they have a lot of insight, but they're not the only tools. The Firebug is a Firefox add-on. The net panel in the Firebug right here. In Firebug, the net panel actually gives us some waterfalls and gives us some timings, and is a good indication, is a good way to visualize some waterfalls. Good for Firefox. HTTP Watch also has a Firefox plugin, but if you like other features that come with Firebug, Firebug does also provide a waterfall capability. Again, this is what Google looks like through Firebug. On Chrome, which does not have an HTTP Watch plugin, or a way to be simulated from Web Page Test, there's the built-in WebKit developers tools. Actually, it's also available on Safari. That sort of shows you waterfalls as well. So to get to them, you click on the little wrench there, and there's a developer tools, and there's a way to go and look at all the resources and the assets that are coming down. There's lots more here. There's profiling, and there's storage, which shows you what the cookies are about, kind of like what Firebug provides for Firefox, but also a bit of capability for waterfalls. A little bit less on the timing side issue. HTTP Watch and Web Page Test actually give us a little bit more granularity there. But for a basic waterfall view, basic look into headers, and a basic visualization of what's going on with the site, the developer tools in Chrome and Safari are actually a good place to get some basic idea of what's going on. We use these when we're doing a lot of spot checking. And if somebody comes to us and says, I'm very interested in how the site behaves on Chrome or Safari, we'll end up using the developer tools to get some insight. I've been showing the Google pages, which are, if you look through them, they're very, very small waterfalls. I'm going to show you what a more real mortal waterfall looks like. This is actually a snapshot from Web Page Test. It's a very average site. It's just a sample site. This is what a waterfall essentially looks like for the average page out there. When you look at a waterfall chart, as you can see, there's lots of resources down here. The two main elements that you want to start with are the HTML itself, which is usually the very first request, the container, if you will, that sort of loads into the browser and tells the browser what resources to fetch, and then all the resources themselves. So as you can see, we first fetch the HTML up here. Each of these lines is a resource that's downloaded by the browser. We'll talk about the color coding and timings in a second. So that's the HTML that gets downloaded, and then all the resources from that HTML that get downloaded all the way until the page is rendered and ready to be used by the user. So we have the HTML and we have the resources. Generally, just for your reference, this area from here, from where the HTML is generated, sent to the browser, and the browser stops downloading all the resources, it's what's usually known as the front end. And the back end is how long it takes. It's basically this right here. It's how long it takes for the HTML to be generated from the server, which in waterfalls look like essentially time to first byte. That's how long the server took to generate the HTML and send the data to you. We'll talk about that in a second as well. This is why we hear a lot about solving the front-end performance problem. As you can see, this is obviously a timeline from left to right. A lot of time goes into downloading the resources and fetching all of them until the page is ready. So this is what a basic waterfall chart looks like. This is what, you grab the resources. This is a visual representation of what's happening with the resources. You get a bit of an idea for concurrency. You can see that over here resources are being downloaded one at a time. Over here they're being downloaded two at a time, although if you really think about it, these are also two at a time. There's one here, but this guy is still going. So at any moment there's two at a time. This is likely an IE7 browser that allows us to do 2 downloads at a time. Over here we'll see that we have 1 at a time happening. These are probably JavaScript resources that are blocking. You basically, the point being that you get a visual representation of what's going on. A lot of insight. It's a really good way to kind of get a visual feel for what's happening on a browser when it loads a page. Let's do a little bit of a analysis on what waterfalls essentially show us. For me, there's 3 big takeaways, 3 things that I use a waterfall for. I look for timing information on a per resource basis. So I want to know how long that JavaScript took. I want to know what the server wait time is for certain resources. That stuff I get from a per resource level, and the waterfall resource granularity gives me that. I also want to know things about the overall timing of the page. So I want to know when it started loading, when it started rendering, when it's hit the onload event, when the document was complete and showed me a rendered page. I'd like to know those things. So per object level timing, per page level timing, and HTTP header information. I'm sort of an HTTP junkie, so the more I know about what's happening at the header level, the more I feel like I have insight to what's going on. And one of the good things about waterfalls, and all the tools that I've shown you guys actually have these capabilities, show you what's happening with request and response headers, and that gives us some information and some insight into what's happening at the protocol layer. So these are the 3 big areas that I use waterfall charts for, mostly timing but also some header information. So let's talk about each of these in a little bit more detail. Per resource timing is probably the thing that sticks out the most. So here's I took a little bit of a zoom of the waterfall that we looked at earlier, the big waterfall that we looked at earlier. And each of the bars, which essentially represent a resource being downloaded by the browser, are color-coded. Now, different tools use different color coding and different ways of segmenting the different components of the performance. This is web page tests. I'll show you in a second what HTTP Watches looks like. But this is web page tests, and the color coding here indicates to me a number of things. First, this little band right there, which is like a teal color, is DNS lookup. This is what's involved for the browser to do a DNS lookup on a domain. It can't make the first request to a domain until it does the DNS lookup, so some time goes into that. I see that here. Notice that that time isn't on any of these guys down here because they're from the same resource and the browser's already done the DNS lookup. So that's something that's important to me. I know that the DNS lookup took this wedge. And all the tools, by the way, can give you breakdown of what each of the components are. Right here, this 1955 is the overall time associated to this resource, but the per object breakdown is something that the tool will also give you. So in web page test, for example, there's a little table that tells you what all these timers are. So that's DNS lookup time, 1 packet round trip. You send a request to a DNS server, you get a response back, etc., etc. Then the connection needs to get set up. So the orange band is the TCP connection time. So here we see all the time associated with a 3-way handshake that is associated with a TCP connection establishment. And this is one of those things that's limited by whatever your access bandwidth is and whatever your bandwidth and latency is to the server that's terminating the TCP connection. That's the orange band. Then the green band gives us our time to first byte. So this is how long it took from the time I sent the request, the HTTP request to the server, to the first byte of the response. So this is usually the latency of the network between me and the server, and whatever time the server took to think about the response before responding back to me. We generally notice larger time to first bytes on HTML, which is dynamic content, needs to be generated on the fly by the server, than we do for all the other resources. So the components that go into time to first byte are latency and essentially server think time, which we'll see more of in HTML, but a bit less of in the resources themselves. So that's another important component in timing that we need to see. And finally, it's the download of the content itself, which is the blue bar. And the size of the blue bar is basically going to vary based on how big the object is that you're downloading. So the size of the object factored into the bandwidth between the client and the server will essentially affect the length of this blue bar. So we see 4 major components here. We saw how long it took for DNS to show up, how long it took for us to establish the initial connection, what the time to first byte for each resource is, and what the content download time is. And you'll notice that it sort of varies based on resource. So on this first resource, which is the first resource that I'm fetching from the page, I just made the requested page. I have to do the DNS lookup time, I have to establish a TCP connection, and I go through a request and the response being downloaded. On my second request, I didn't have to do a DNS lookup, but I did set up a second TCP connection because I like having 2 TCP connections at the same time. This is what the browser does. But on my third request, the browser doesn't even set up a TCP connection. It's reusing this TCP connection. So you'll notice that different components go into the timing of different resources. And the color coding really helps in that aspect. For example, if I looked at a big waterfall and it was every resource had an orange bar on it, I know that there's something weird going on with the connection management between my browser and my server. So that's an area that I would know to go dig a little bit deeper into. So this is sort of the per object timing that we can get from, again, this is web page test, and we get a visual representation of what fraction or what portion of each object's total time was associated with its overall performance. HTTP Watch also has a color breakdown. It's a different set of colors. Here's a quick, this is like a little help panel that we see from HTTP Watch. Again, you get the little bars, you get this color coded a bit differently. The server think time and HTTP Watch, for example, or the time to first byte is green, here it's red, and web page test it was green, here it's red. And each of these timers, as you click on them, if this was interactive, you'd see that. If you click on them, you get the actual timings associated with each. You get a little bit of that here as well in this table. So that's the per object breakdown as far as timing goes. There's also, so let's step back a little bit and look at the page as a whole. There's a few things that we take away when we look at a waterfall. Again, we'll go back to our sample page from HTTP Watch. Few key takeaways. Again, for us, when we look at waterfalls and try to analyze performance, we look for very key metrics. The primary metric we'd look at is the number of round trips. We know the round trips are affected by latency, so we want to know how many round trips it takes to load a page. In this example, there's 63. That's all these resources together. Web page test and HTTP Watch actually, and some of the other tools also give us two key timing metrics on a per page level. So earlier we talked about how you get per resource timing. We also get per page timing. There's a green line in web page test that gives us when the page starts to render, and there's a blue line that shows us when the page hits the onload event, or what web page test calls a document complete time. This is essentially how we consider the time that we consider a page has rendered and is visible to the user. So we see that there's two per page timing indicators here as well. So just like we got per resource timing indicators, now we have per page timing indicators. So I knew how long it took for each resource to go through its timing and what the performance impact of each resource is, but I see how it all adds up and how it affects the page in general. So I see I have a start render time of, in this case, 1.9 seconds and a load time of 9.5 seconds. So this, the green bar here is the start render, and this is essentially the onload event. So those are two per page metrics that I can grab from Waterfalls, as well as per resource metrics. I also kind of like to know what the overall payload of the page was. Now, I showed this. Is this a page that took 770K? That's not something you can tell right away from here, but all tools have a way to aggregate essentially the blue bars, right? Aggregate the total number of bytes that are downloaded and to give us an indication of how many bytes are associated with a page when it comes to download time. Let's go back to our Google Waterfall real quick. I've included the summary that web page test actually provides for us. Again, this is the waterfall. You'll notice the start render and the end render. These are the resources that are, and the unload. These are the resources that are being downloaded. And here are some key timing metrics. It tells us that the start render is at 0.7 seconds. The document completed at 1.2 seconds. There were a total of 6 requests. There were 25K. Again, it's a really lean page. That got downloaded. So these are key metrics that we get here. So these two things put together give us a lot of good information that are both visual and factual about the timings on the page. We also talked about this blue line and how this is the onload event or the document complete time. Notice that sometimes you can get resources after this time. This is usually what happens post onload event, which is when the onload event is something the browser fires that says the page is kind of ready. But there's ways and there's techniques and there's mechanisms out there that use the onload event and load things into the browser after the onload event. Those are things that won't necessarily be visually available to the page. At this point where the onload event is fired, the page is generally visually available to us. So that's also something to keep track of. we don't always expect the blue bar to be at the very end of all the resources. Some things sometimes happen after the page is rendered and is ready for the user. I also talked about, so we talked about per resource information and timing that we get. We talked about per page timing and information we get. We also get request and response headers. Like I said, I'm a big fan of these things. I think they give a lot of insight. Here's a couple of samples of a request. This is all the request headers. Again, I got this, I believe, from a web page test. All the other tools have this available as well. I can see my request headers. This is the request for the home page at Google. These are all my request headers. These are the response headers that Google sent back to me. I can analyze caching information from here. I can analyze if there was any connection information from the request. I can see that there was a connection keep alive, so that I know this is a keep alive connection. I noticed that the response page was compressed. That was about 5K of HTML coming down. So this is valuable information that can help us better understand what's happening with performance of a page and give us more insight to what's going on, and ultimately help us diagnose problems and address performance pain points a lot better. Let's do a quick summary of everything that we've talked about. Waterfall charts are very cool. We use them a lot to analyze performance, to get insight into what a page is doing. They're a representation of how a browser consumes the page, and it really, really helps when we see this visually. It lets us really get a good feel for what a page is doing and how responsive it is and what the key performance metrics are on that page. We do get good timing information on a per object, on a per page level, so everything that we need with performance and timing is available to us. We just need to dig and get that information. When you look at it big picture, the color coding really helps figure out what fraction of each resource's timing went into each piece or each component of performance, or the vertical bars in web pages, for example, give us what the start render and end render are, and the onload event are, where they fire. So we see some things at a big level, and then we can drill down and get good information on a per object level. And it's a great way to get insight into pages, get insight into page performance, look for timing, and of course look at HTTP headers and get some insight there. That's basically it. Again, put in your questions. Actually, I'm going to look at questions now and see if there's any questions. Good. We have a couple of questions now. David wants to know how SSL affects this. I'm sort of paraphrasing a little bit. How SSL affects these waterfalls. We didn't talk about SSL at all. That's actually a really good question. We didn't talk about SSL at all. SSL session setup does affect performance. There's timing that goes into how long it takes for an SSL session to be established and an SSL handshake to occur between a client and a server. Web page test actually shows that in its waterfall charts. I didn't do a web page test sample with SSL, but it does actually have a different, I think it's a purple part of the bar that's associated with SSL. So you get some timing information there. It is an important component, and it's not something that we can ignore. So it's a very good question. There are some mechanisms in these tools that show us what the timing is that's associated with SSL. You sort of need to be a little bit more network-centric to see that, because inside the browser level, actually what's happening on the network with the SSL connection isn't always visible. So you kind of have to have a little bit of the tool needs to have a little bit of a network visibility there to see that. But there are tools available to gauge that, and usually for general SSL performance impact, we can see a lot of it from web page test that shows us what the timing is associated with SSL. I have one more question here from Sam. Let me read it. Okay, I'll paraphrase. It's essentially targeting what we've talked about so far. So the question is, what happens for multiple page tests? And what I'm going to assume that means is flows. So Sam, I hope I'm getting your question right. So everything that we looked at right now and general waterfall analysis gives us insight into a single page. What happens with a single page? Web page test by default shows us essentially what's happening with a single page. But a flow or a multi-page test is one where you start on page 1, you go to page 2, then you go to page 3. It sort of mimics a little bit more what an actual customer experience or customer movement through a site would be. And there is definitely performance within the flow that we care about. For example, we kind of care about how long a user takes between page 1 and page 2. What's the user think time as they flow through? Or how is cacheability on page 1 affecting cacheability on page 3? Those are things that are important to us, and ultimately it's the flow that determines what a user's real experience on the site is. So it is a very good point. It is a important, albeit a bit more complicated, piece of the performance puzzle. And as far as the tools go that we've talked about, HTTP Watch is a very natural way of showing you flows. With HTTP Watch, actually, you know what? I may have HTTP Watch here. Let's see if I can start it up for you guys. Yeah, it's right here. So if you can see my screen, let me show you a quick example of how HTTP Watch works. I just press record and go to, what do I have here? NewYorkTimes.com. Huh, NewYorkTimes.com doesn't like to answer, so let me try a different one. I'm a big NFL fan. Let's go to NFL.com and see if there's anything going on there. Okay, here we go. Here's some info on NFL Networks. NFL.com. You'll see this is essentially the layout of. I'm still looking at New York Times. It came back a bit late. This is NFL.com. Here are all the resources. You'll notice that I can basically group my pages, and as I flow through a page, and let's say I went to the Colts and looked at the Colts, as I flow through the page, it basically accumulates. And I get to see every one of my pages, and I can dig down into a page at a time, and I see general flow information because I see timings on each of those pages. So there's a little bit of flow information that's available there. I'm going to go back to my presentation here. Web Page Test also has a scripting interface that lets you write scripts that traverse through multiple pages and get some timing information there. So it's an important question. It's an important aspect of performance, and it's something that we should keep in mind. And the tools do offer us some ways to measure more flow-based performance metrics rather than per page or per object-based metrics. So we talked about per object metrics and per page. The third component of that is indeed flows, and that's something important to keep track of. Okay, we were kind of running out of time. I just want to do a quick plug for upcoming webinars for us. We talked about the very basics of waterfall charts in this session. We're going to get more into waterfall charts and talk about a bit more advanced concepts. How do we use the information that we get from a waterfall chart? How does it expose performance problems? Things like that we're going to talk about in our next session on waterfall charts. We also have a couple of webinars coming up with different things that affect site performance, be it third parties or just general action plans for fixing the site's performance. We have those, so I encourage you guys to visit us back for those webinars, and we can share some of the insights, some of the things that we've learned from the field with you, and hopefully help you out in your performance battles. Also with Strangeloop, if you're interested in seeing what your site performance is and maybe how Strangeloop would help it, you can go to our website and test your website's performance and see where the performance pains are. And we also, Josh, our president and founder, has a good blog on webperformancetoday.com that talks about the different performance issues that we come across, and he blogs about it and has great opinions to share. And of course, strangeloopnetworks.com, our website, if you want any more information on what we do, our products, or want to talk to us more about the stuff that I talked about in this webinar. That's it. Thank you very much for attending, and I hope to see you again in our future webinars. Have a good rest of the day.